now do mirror ray problems. Number 6. And in this problem, we're given an object out here, and we're to find the image of that object using a convex mirror. This one's going to be a convex mirror because I can see that the mirrored surface is actually bowed outwards. So let's go ahead and find where that image is located. Now for this, much like we had for the concave mirrors, we have 3 principal rays. And the first ray that we're going to use is a ray that looks like it goes through the focus. So ray towards focus, reflects parallel to principal axis. So if we go ahead and see what that ray looks like, we go with a ray towards the focus. Now I got to ask, does it actually reach the focus? And the answer would be no. In fact, it hits the mirror and it reflects off parallel to the principal axis. So that would in fact be ray number 1. Now our second ray that we're going to look at is that a ray parallel to the principal axis reflects as if it came from the focus. So what are we saying in this one? Basically we have a ray that goes parallel to there, and it reflects as if it came from the focus. So I'm going to start out here at the focus, and I'm going to show the reflected ray from where it hits the mirror. Now if I look at these two, ray 1 and ray 2, if you look at ray 1, is it ever going to converge with ray 2 on the object side of the mirror? And the answer will be no. So what I'm going to do here is actually extend the reflected lines, and here is that extension. And what I find is that where they cross is right here. So I'm actually expecting the image to be behind the mirror. What kind of image is that? That would be virtual, and it's also going to be upright in this case. Now there is a third ray. Okay, it's a way to check. So ray towards center of curvature reflects back on itself. Because remember, any ray through the center of curvature is naturally perpendicular to the surface. It's a radius. So I'm going to show a ray through the center of curvature. So I start here at the end again, take it through that center of curvature, and if you notice where it intersects the other rays, remember it doesn't actually go through there because it reflects off back on itself. So it's the ray that's coming in this way, reflecting that backwards. But if I extend it, once again, where the reflected rays intersect, since I took them from the tip of my object, that will be the tip of my image. So I would just draw my image right at that point of intersection of the reflected rays, and once again, it is a virtual image. And that is the